And welcome. We have another lecture today with regards to AWS Infrastructure Services, sponsored by FAB-IT Solutions. And hopefully this is the fourth one that we have. We're going to successfully upstream it into the Google YouTube as well, so it's available for individual access. Ich habe die ganze Präsentation auf Englisch gemacht. Wir machen einfach weiter auf Englisch. Und für die Leute, die Schwierigkeiten haben zu verstehen, ich versuche einfach zu langsam zu sprechen. Wenn es nicht langsam genug ist, dann sagen Sie Bescheid. Introduction to AWS Infrastructure as a Service. Amazon has many services and ever-growing and implementing the most popular solutions within its cloud. We know that the Amazon is the most mature cloud services that are available, and the competitions are Google Cloud and also the OpenStack. OpenStack is more from a scientific purposes, and it's used by NASA. But from a commercial perspective, they don't have that many services available to be used straight away. And the packaging and the process in the Amazon Web Services I find more efficient and more attractive to most of the businesses that are out there. And most of my clients, they've been using AWS for the same purposes. These services are not only available as a standalone, such as platform as a service, software as a service, infrastructure as a code, but they also allow the customers to build their own custom solutions on their infrastructure, namely as infrastructure as a service. These terminologies, they are standard ISO terminologies that is used in the industry at the moment. And when you have a platform as a service, or software as a service, or infrastructure as a code, these services cost more. But to be flexible, Amazon made it available through the infrastructure as a service, which is more like an older model. But the only difference is, in the older model, you had the separation between the network topology and the systems and the duties of every segment. In this methodology, it is possible to have all the old standards come together and available and managed either by one parties, one department, or multiple departments. But it's a lot easier to manage, and we'll see why. A quick example will be, for instance, if you have Oracle database, this will need to have a network infrastructure, then you have to have the operating system on top of it to be able to run the Oracle services. In the Amazon, you have RDS, which will be a platform as a service, which is more expensive, but when you buy that, you don't have to worry about the topology, network, or operating systems. You can focus on the database administration and anything that is related to the database. So all these things come with a cost. They fundamentally have tendency towards open source philosophy, but on the other hand, they do have some Microsoft solutions for few customers with less sophisticated needs. We know that open source started around 91, 92, when we were the first rebels who actually participated in that. And now the whole internet is actually running on open source. But it's also available commercially, such as Red Hat Enterprise, which they're not allowed to sell the services, but they can sell they're not allowed to sell the code, but they can sell the services. And the example is when you have a Red Hat Enterprise operating system, on the other side you have CentOS, which is community supported, which obviously you need more SMEs or technicians when you're running on a CentOS in comparison to Red Hat Enterprise solution. They're always working on cutting edge technologies and just recently have introduced blockchain solutions based on Ethereum, EVM, and Quantum respectively, using proof of work and custom proof of stake consensus algorithm. As some of you might be acquainted, the blockchain is the future. and all the industries are competing with each other in this era. We're not covering that in this particular lecture, but that shows that they're always on the cutting edge. And the services that they have, they are vast, very big. But I selected IaaS as a fundamental service to have some exposure for the other services that we might have in the future for the Conium, or the Conium clients. Any questions? The first part of the lecture, we are going to have subnets, introduction to subnets, route tables, internet gateways, DHCP options, NAT gateways, VPC peering connections, network ACLs, security groups, VPNs, elastic IP, endpoints, and endpoint services. A lot of these terminologies you might be already acquainted with, but Amazon has their own terminology, which is in parallel to the previous one. For example, in this particular case, when you look at ACLs, originally ACLs were used by IBM as access control list, but in this context, Amazon is using it for NATing and the firewalling. And if you're familiar with the firewalls, then you will not have that much of a problem understanding it. So here's a very simple diagram of the VPC. The VPC, Virtual Private Cloud, is simply the virtual network. And that is, again, another terminology that is used in cloud. You can see at the outer layer you have the regions. Within the layer you have the VPC. Then you have the availability zone A, B, and C. Then you have a router for connecting to the internet. You can see the destination IP is 10.0.0.16, which means it's private. So within the VPC, that's the beauty of it, you can have a private network within. Sorry for that. Any questions? This is a very simple overview of the VPC. You can see the name of the VPC at the beginning, FAB-IT Solutions. You have the VPC ID, and the state has to be always available in order to have it functional. And yet you can see that IP version 4, CIDR, that we mentioned before. So you can see there's a classless into the main routing because you cannot use a unique IP, since if you use a unique IP, you will have conflict with other IPs in the internet. So in order to do that, you have to have a subnet. And within the subnet, you can have your own classes repeated and multiplied in the VPCs. You have this DHCP option set. DHCP is also another service that is available for free through AWS. But that doesn't mean that you cannot provide this service yourself. If you decide to, you can have the DHCP server running on your own servers and basically having the leases and distributed among the nodes. But because this service is for free, I've taken it as well. The main intention of this IaaS that I'm creating here is to find all the services at the optimum price. And those are the businesses that they go for this sort of model, because at the beginning they don't want to spend that much money, especially if it's a test system. And in the test system, you would like to have more access or more visibility through the actual infrastructure to see how your software is working. And then in the production, you can use the service as ready instead of recreating the infrastructure yourself. Here you have the main routing table, main network ACL, and these unique identifiers are necessary when you want to access through the CLI, which means when you have a system, your own system here, you can actually access the AWS and control all these resources on the AWS through a command line interface. We'll see how that works, but basically you can construct the whole infrastructure, repair the whole infrastructure, or update it. This CLI could be an executable, it could be a Python shell, or it could be a bash. But from an engineer's perspective, when they are capable with the bash, it will be a very good skill to be used in this area. Another good thing about AWS is when you have the VPC in front of you and you have a problem with it, you have direct access to single modules right below it. For instance, if you think the routing table has got a problem, and if you're in the graphic user interface, you actually can click here and directly go to the root table and check out your routing status, whether they're correct or not. In a command line interface, normally that is not as visible because it's not multidimensional, it's very one-dimensional. So I had a lot better overview for troubleshooting as well. Same as network ACLs, the HTTP option sets can be accessed directly by clicking on the hyperlink. Any questions? Now here you can see, going back to the CIDR block, you have two different blocks here. On the AWS you have VPC1 and VPC2. Now the interesting thing here that you can see that 10.0.0.16 has been repeated. If that was within the same VPC, would have been a conflict. But here we have subnet 1, which is on the 10.0.0, on the subnet masks of 17, subnet 2 on 10.0.128, and subnet mask of 17, and the VPC being on 10.0.0.16. And on the right side, you have the repeat of the 10.0.0.16 with three subnets. Subnet 1 of a 0 to a 128, and the third one is 10.2.0.0. And they all have the same subnet mask of 17. This might be a little bit confusing if you're not familiar how the subnet works and the classes work, but that is not much of a problem. Basically, this is showing you, for instance, if you have a production on the left and the right side you have the test, they can coexist with having duplicated subnets that they are not conflicting with each other because they are restricted. Any questions?
And you can configure the DHCP because it is also available as a service, the DHCP.
Very good question.
Can you configure it yourself?
No, you can't.
It's a good question.
Yeah, very good question. You either can run the DHCP yourself, or you can just leave it to the AWS to take care of it for you. But choosing the subnet.
To choose a certain range of IP addresses.
Correct.
Distributed, you can say it.
The DHCP is smart enough. Depending on your subnet, it will change. It will choose the range from that particular subnet.
Automatically.
Exactly.
Okay.
But it doesn't give you lease permissions. Mm-hmm. So if you want to do detailed configuration of the leasing, then you're better off creating your own DHCP server, which most of the times is not necessary from a practical perspective and business. Okay, now this is a linear presentation of that diagram. You can see that on line 1 we have subnet 2, and on line 2 we have the subnet 1, and you have the subnet IDs, and you have the state, and you can see that they're both having the VPC 02C1 and IP version 4 CIDR of 24 and 10.01. And availability zone is different. Now, when it comes to the availability zones, you always, per VPC, you have 3 different availability zones, not more. Can anybody tell me what would be the purpose of that? Basically, it comes to the load balancing. So when you are load balancing on the same VPC, the availability zones allow you to do that. Availability zones are always associated with the same geographical location. So if your 2 VPCs are in New York and Frankfurt, then you cannot jump availability zones across the countries. But if you just want to be in Frankfurt, then you can load balances in A and C in Europe. Now another question. Why would you not want to load balance between Frankfurt and New York instead of using availability A and B or B and C in the same location of Frankfurt? Because it takes longer to go through New York, basically. So from that purpose, it's very useful. So you can see the routing tables and network ACLs as well, which we're going to cover shortly. Again, below all the information available to you, and if there is a problem, by clicking on it, you can directly go to the relevant screens. AWS also supports IP version 6, but we're not covering in this particular lecture because we don't have anyone using it at the moment. Okay, this is the VPC routing example. So you have the routing ID, and if it's main or not, then the VPC ID and the owner. Now the routing that you have, it's important that you do it at the AWS level, because on your server, the routing table will be different to the AWS. And on the AWS, if the routing of your server is not connected to the VPC routing gateway, you will not have access to the internet. So if your server is supposed to access outside, there are things that you have to control. And one of the main one is that the VPC routing gateway is active and is routed. It's the first thing to look at. This is a practical problem we had before. We were searching for very complicated stuff, found out it's very easy. You just have to get a route from outside to be able to connect to the internet. Especially when you have a public IP, which we're going to cover shortly. Any questions? Okay, now this is the diagram of what I just said. So you have the AWS on the outer layer, which is related to the region. Region will be Frankfurt, Sydney, New York. Then you have the VPC on the CIDR 10.00.16, and you have 2 availability zones in this particular case. And you can see the router is connected to the internet gateway to go outside. So if you don't have the IGW ID, the internet gateway route, basically your server cannot go out or come in. There are no connection to the server. And you definitely need the local route as well for the loopback. Now at the top you can see, and you have an IP version 4, 10.0.0.6 for that particular server, on the subnet 1. You also have elastic IP of 198.51.102. This elastic IP is a unique IP for external IP to be accessible from internet. So this is a public IP, but there are 2 forms of public IP that can be assigned to your server. One of them is elastic IP, and we're going to cover it shortly. Any questions? So here you can see that the internet gateway is being created, and the state attached is very important as well. Even if you have routing, if the state is not attached, you're not going to be able to go outside. The HTTP option examples. This is how you create the DHCP, very simple. For the ones who actually tried before to create the DHCP, you know that it's not so easy to configure it, but it's getting easier as we go along. But in an AWS case, is very simple. The stream is not working. Now the NAT gateways. Now when you have the routing available to the servers and outside, you still need to have protection. And that's where you create the NAT gateway. In this case, you can see the destination of 10.0.0.16 is going to local for routing, and 0.0 going to the internet gateway for going outside. Why? Because these are web servers. Web servers are supposed to be available from outside. But we don't want the customers to be able to have direct access to our databases, exactly like the architecture that we're building at the moment on the infrastructure that is available. So the NAT gateway is blocking any connection directly going to the database servers. So it's allowing the client to only connect to the web servers. Then the web servers are allowed to go to the second subnet to access the database servers on specific ports. Any other ports is blocked. And this is done very easily on AWS. Any questions? Any part of the diagram that is not clear, you can ask. This is NAT Gateway's example. So that's a more linear demonstration of that. You can see in this particular case it's deleted. So if it's deleted, it's not going to be functioning. So in order to have a NAT, first you have to have a gateway, very similar to the routing. So you have a NAT gateway, you have a routing gateway. But after having the gateway, you have to construct it. And if you go to the next level, it's a VPC peering example, which we didn't create here, to have two VPCs in two different countries. Our VPCs are in Frankfurt, the ones I've created here. But it's very simply done by giving a tag of the VPC peering, select the local VPC to peer with. When you click there, it will give you an option to select the VPC that previously created and the acceptor. So basically you create the VPC in Frankfurt, you create the VPC in Sydney, then here you just connect them together. So they will be paired up together. Now you have the network ACLs. It's a little bit deeper filtering when you're receiving connections from the customer or going out. Here we have the inbound, rule number 100 for the SSH, allow. All other traffics do not allow, deny. Outbound, we have the TCP. You can even define a particular IP and allow it to come in at a particular range and deny the rest. So you can restrict it by IP, or you can restrict it by service and port. Now in the subnet of the 10.0.0.24, you have inbound of all traffic, SSH, coming from that IP and that subnet, and the outbound traffic, SG1A to B34, whatever the name is. Which means you have two different levels of security control, but they do the same function. Because within the kernel, you might want to have more flexibility, but from outside, you don't want anybody to come in. So that's the VPC level, and that's the AWS level. And it's blocking all other traffics. And this is the terminal that we talked about. Any questions? Now to show that in a linear manner, we have created the ACL example. We give it a name, FTS01 ACL. We have the ID again. In this ID, as I mentioned previously, can be manipulated with the CLI for edit and update. and this one has been chosen as a default and associated with 2 subnets. Which means when you create an ACL, you don't have to recreate it over and over again for every different subnets. You can have the names there and associate it with the new subnets as well, which is what most of the people do. And here you can see the rules. The rule number is not really important. You can select a number for yourself. As a matter of fact, I was expecting that to be generated automatically, but it's not. You have to sometimes people get confused. What am I supposed to put in there? 100, 102, 200, 300? Actually, it doesn't matter. It's just for AWS internal accounting. You give it a number. You can either select the service or you can define the port. So in this case, we have 22 SSH accessible, HTTP, and another HTTP 8080, which is, if you're familiar with Tomcat, and the HTTPS for 443. For the HTTPS, it's a little bit more sophisticated because you need the certificates, which we're going to cover shortly. Any questions?
What is the source then here with all the IP addresses in 0? What is the source?
Well, this is inbound rules. So that means everything.
Oh, yeah. Okay.
And you have outbound rules as well, which I didn't mention. Basically shows different directions. Which means SSH22 from anywhere, allow. And 8080 is normally a Tomcat. But you can define it as well. You can change it. Any other questions? Now this is a security group example. You can see it's very similar, but at the outer layer. So you have the outer layer and you have the inside layer. So in the inbound rules of the security group, you have HTTP, also from anywhere, SSH also from anywhere, HTTPS also from everywhere. So if they are not synchronized exactly, then one of them will block it. The diagram will explain it a little bit better. I think you're a little bit confused now. Basically, there are 2 levels of security checks. You also have virtual private gateway examples. Again, another gateway. If you want to create a VPN with a customer, you have to go through the VPN gateway of the AWS before you can connect the customer. For instance, in my previous 2 previous contracts, I had a project with AXA, and they were creating a security system on the mobile to be able to call the Polizei in 15 minutes response if somebody is in trouble. In order to do that, some of the connections had to be encrypted, which means when you create a VPN tunnel, what happens is nothing can penetrate from outside the tunnel, but the streaming within the tunnel is not encrypted. So basically we were connecting to Bosch, and the Bosch was connecting to the Polizei. So this information will not be able to be intersected or changed. We had some GDPR problems as well, so we had to put some of the data on the cloud, AWS, and some of them off the cloud. So it was a hybrid cloud that we had to have. So in that particular cases, VPN is very useful. And I think we have some VPNs here as well for the custom homes for special purposes. So after creating the VPN gateway on the AWS, then you can create a VPN connection. And again, on the VPN connection on the AWS is very simple, because you just give the name tag and the virtual private gateway that you just selected beforehand. Then you have the customer gateway ID. Then you have to create your tunnel. So you have 2 CIDRs for the inside and the pre-shared key of the tunnel 1 and 2. This terminology is only understandable if you have already created VPN before. And you can see it's extremely simple here. When you bring up a server, and if you want it to be accessible from outside, you have to ask the AWS to assign an IP for the server. This will be a public IP. Which means if it's a web server running on this IP, if you put into HTTP and the IP number, you can access directly your server. The problem with this is, when the server comes up with that public IP, if you for some reason you need to bring down the server, you will lose that IP. Which means you have to go and update all your services with the new IP that AWS is assigning to. Whether this is a commercial strategy to charge people or not, I don't know. But the elastic IP, it always stays the same. So when you purchase an elastic IP, then you associate this elastic IP to your server. This will be the public IP that is accessible and is portable. Which means if you bring down the server and bring it up again, the IP stays the same. So if the DNS is associated with the IP, the DNS does not have to be updated. Your application does not have to be updated. Even better, if you have a new system that needs to have this IP, for instance for test purposes, and you don't want to bring down the old system, you basically detach this IP, attach it to the new system, and it'll be directly accessing the new system. Hence, elastic. Creating elastic IP is very simple. You ask AWS to assign one, you don't have a choice. And here's what's created. Well, it gives you the warning. If you associate an elastic IP address with your instance, your current public IP address is released, which we talked about. So not only shutting down the system will release that IP, when you're bringing up the system, you have to think about this, that am I going to use elastic IP or not? Because even if you get an elastic IP afterwards, you're going to lose that IP which was configured previously. Any questions? Is the speed okay? Now, you know that nobody works with IPs these days. They all have DNS names and nice names that are associated through the DNS. But if you have a quick test system that you want to have a nicer endpoint, which is not an IP, you can choose that from the endpoints examples. Especially when you have a service from AWS, you'll have this nice endpoints like Amazon EU Central Cloud Formation. Then your IP will be associated with that name. Then in the web browser you can use this name instead. So it's more descriptive and it looks better. Here's an endpoint example. VPCE, that's the ID of it, that's the VPC ID of it, and that's your service name. S3 is one of the services that AWS has, which is the bucket or storage, but they're not persistent. We have different types of storage on AWS, and S3 is not the most efficient one. EBS is the more efficient one that we're going to cover shortly. Any questions? Now, you have also endpoint service examples. So if you have a special service and you create the service, you also can give that endpoint service name instead of the AWS service name. This is all when you don't have DNS. If you have a DNS, you don't need any of the services. That costs money. Now you can see a full blast model of a VPC. On the outer layer, you have the internet gateway. You have 3 subnets within it. You have one of them accessing outside. You have one of them not accessing outside, but it's accessible from inside. Meanwhile, you also have a VPN connection. So the VPN connection goes from virtual private gateway into the customer gateway and the corporate network, which means this server will have access to that. At the top one, you can see that there is a private IP of 10.0.0.5. Meanwhile, you have an elastic IP of 198.51.101. Sebastian, what would that do? The elastic IP on the top one. Because we don't have any elastic IPs here or here. Well, that is available basically from outside. So if you have a web server on that, they can connect through there, then access the other servers for restricted services, which we discussed before. You also have IP version 6 here. So because you have two different classes of two different versions of the IPs, you will have to have two different internet gateway IDs as well. This is a version 4 and this is a version 6. And the local as well. So this is a loopback of the version 4 and the version 6. In these two cases, you have only private IPs because these are not accessing outside. In this case, you have the loopback and the VPN gateway ID. So you can see this is VGW ID, this is IGW ID. Because this is going through the VPN, only accessible through the VPN, nothing else. This one, the whole internet can access it. Just take your time for a couple of seconds, have a detailed look at the picture if you have any questions. I know it can get a little bit complex, but I hope I'm explaining it at a bird's eye view as well. And you also can see you have A, B, C availability zones, but everything is on one region. For instance, Frankfurt. Okay, that should give enough exposure to the infrastructure model. Now we have IAM management. Well, this infrastructure model has to be somehow accessed, and there are permissions for this access. There are very sophisticated permissions, same as Unix. You want to log in somewhere, you have to have username, you have to have password, you have to have SSH, and so on. A lot of similar technologies are used here. So you have an IAM dashboard, which is available through the link above there. And you have to go to the security status, and 505 is complete, then you're pretty secure. So first thing you do, delete your root access keys, activate your MFA on your root account. MFA, are you acquainted with? It's multi-factor authentication. It's available for your banking system as well, or the sysadmins, when they want to access the system, they have this little key. That's also multi-factor authentication. And Google has one that generates numbers, algorithmic, so it protects the system. Then you have to create individual IAM users and groups and apply IAM password policy. Now what does that mean? So the IAM groups is a group. For instance, administrators access. You don't want to redefine that over and over again. So you create a policy for this group and associate it with it. And if it's necessary, you just assign it to a group. For instance, if Fuad comes in, I just put Fuad in there. I'm not going to create another policy for Fuad. I'm not going to create another policy for Sebastian. Now, we have a role and we have a policy. Policy is assigned to a group. But in some cases, you have special permissions that is needed to be given. You don't want to change your policy because of the individuals. Same as the law for a country. You have a policy, but then there are individual rights. So the individual rights, you should not change the policy. Therefore, you cannot assign a role to a group. You only can assign a policy to a group. The policies can be also defined in JSON format for the programmers. We're not going to go too much into that. Here you have a user, and user ARN is at the top to be able to access it. It's a FAB-IT Solutions to be able to get into the system. You have access ID keys, access key IDs, two of them here activated. And also you have an SSH key ID. For the ones who know how you get into a Unix system, so you know how the SSH works. And that's where you define your SSH key ID. But you also, on top of that, you have an access key ID, which is used specifically when you want to run the CLI and the AWS services from your system, which we're going to cover in a second. Any questions? Now you have IAM roles. which I mentioned before, it could be exactly the same condition in the JSON, but it has to be a role. Why? Because role can be assigned to an individual, but it cannot be assigned to a group. So the group has policy. Role can be assigned to an individual or a service. For instance, you say this server is allowed to do this, 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 this. You cannot give it a policy, you have to give it a role. So that's the main differentiation between the roles and the policies. Now, above you can see different types of roles. There are predefined roles and policies, but if you find something which is not in the list, you can create your own as well. For instance, here, FAB-IT Solutions admin, I've created my own role to be able to assign to AWS services EC2. So it's not a person, it's a machine. But I'm assigning the role to a machine. But I cannot assign a policy to it. Below, you have the policies. Administrators access. There can be all of us sitting in there.
This role should be in the boundaries of the policy. I mean, if you specify, if you define one role, it should not be in the contrast with the policy.
Very well done. Yes, yes, yes. They should not contradict. That is one of the arts of writing the roles appropriately, not to overlap the policies. If it does that, then you will have a security hole. So whoever is assigned to do this job basically has to be a security specialist. And what is recommended is to use the existing policies and roles. If it's not within those, then define yours, because of what exactly you said. Very good questions. Now we go to the actual machines. Machines are called EC2, the virtual machines on the AWS.
What is behind this naming, EC2?
I have to get back to you on that. I've used the terminology as an acronym for such a long time, I forgot. Elastic Computing something. I'll get back to you. Now, in this part of the lecture, we look at the one instance as EC2 setup and access through IAM, which we just covered. Templates, provisioning pre-configured servers, spot requests. Spot requests are basically like a stock market or eBay. When you want to sell something, you just put it out there, see how much are you paying for it. In the service, in the AWS, they are very expensive. Sometimes you can put in a spot and offer a price, and if they have available, and if your price is appropriate, there is algorithmic calculations that says, okay, yeah, I'll give it to you for this price for this amount of time. Which is very sophisticated as well. From a financial perspective, is also, if you're not in a rush, you just put a spot in there until your server is available. Then you have EBS volumes, which I mentioned before. These are the volumes that are your disks, basically. And the EBS stands for Elastic Block Storage, which is equal to the Linux, the volume managers of the Linux, LVM, Logical Volume Manager, which was originally developed by IBM. You can get snapshots from your volumes, but that does not mean AMI. That's not an image of the machine. It's a snapshot of your storage, which you have in the normal data centers as well. You have security groups, which we covered beforehand. So it's a lower security filtering, not at the cloud level, but at the server level. Now you can distinguish that we have two different levels. Then you have the network interfaces, load balancers, and WAF. It was interesting because I told Peter that we were covering WAF as well, and he thought I said WAFat. I said, no, not weapons. So, when you want to start a server, these images are available. So you can load from these images, then you can configure it, then you can create your own AMI and save it somewhere, and retrieve it back. We have Amazon Linux, we have Red Hat, we have SUSE, and Ubuntu. I'm not going to go into the differences about that, but they're all Linux basically, but different distribution. So, all the first steps that we took, all the previous steps that we took, if it's not there, you will not be able to bring up EC2. Because the person is asking you, says, how many do you want and where do you want it? So if the network is not constructed, if your subnet is not constructed, which we have previously done, you cannot bring up an ETC. And it says, go and create it first, then come back to me. Or you can use AWS services to automatically create it for you, which is custom. But when you cover this and you understand how it works, even if you use the automatic creation, sometimes you need to go and fix some things. So it's good to understand what is the infrastructure model behind it. But because even if it automatically creates it, you still have to go back there and just solve problems or edit it or expand it. And this is what we talked about auto-assign public IP. That if you assign that, if you bring it up, you will lose it. So at this point you can say, do not auto-assign, I will give you my own elastic IP that I previously had. Or you say, do auto-assign, because I don't care. I'm going to get rid of the server afterwards, after the test. Then you have an IAM role, which we created before. You should select it here. In this particular case, is an admin person who will have full access to the server. And you can tell it what to do after shutdown. Stop or destroy. If you do a stop, you're still paying for it. But if you do destroy, then you don't pay for it. Tenancy and the T2, T3 is more performance associated matters. But we are basically choosing the least performance here for our particular test. Now you can see the EC2 is up and running, we constructed one. The instance ID you can see, and the state running. Instance type T2 micro, this is categorization of the AWS, this is one of the cheapest one. Sorry, it's the dead cheapest one that I could create. You don't pay for it until 1 year. And if your account is over 1 year, then you stop paying for it. So you actually can put your credit card and go into the AWS and construct it yourself. And if you need any help, let me know, I can help you out. You can create your own T2 micro for 1 year, you're not paying for it, but there are some limits for it. Availability zone, which we refer to, in this particular case, EU Central 1A. You have the security groups. So you have the inbound and outbound rules. If there is access problems, straight away you can click there and update it if necessary. The AMI ID, this is a standard one that we've chosen. If you have created an AMI yourself previously and you saved it, then you can retrieve that as well. Key pair name FAB-IT Solutions AWS key. And right at the end of the creation, it will allow you to download your private key. This is the last chance and the first chance that you have to download your private key. If you don't do that, you will never have access to the system anymore. And the reason they do that is security. So there is a one-time chance to download your key, then you put it on your server, and if you lose your private key, obviously people can access it. So what you do is you go to the home directory .ssh, and you put in the ID RSA and save it there, and you have to make the permissions correct as well, which is 600. The rest of the information, you can see the virtualization, which is the HVM hypervisor. And you have here the internal IP and external IP. So that's your external IP, public IP, this is your private IP. This is the VPC and the subnet ID. You can see your network interfaces, T2, T3 unlimited disabled, because one of the cheaper instance. And root device type is EBS. Elastic block storage. And these are a little bit more technical information when you want to access the disks. The reason for that is when you have elastic block storage and you want to assign extra storage to the EC2, it is possible. And you can use the LVM, the Linux LVM, to expand what you have instead of recreate the whole system again. If you need extra storage, you can expand it. That's an example of the EBS volume EBS volumes. So you have the volume of ID. It's given 30 gigabytes, and it gives you the state in use. If it's offline, obviously that's your problem, that it's offline, it's not working. You have some attachment information. This is when you are trying to expand or extend the volume, you have to first detach it. So if it's in attached position, attached status, you cannot expand it. So these are more detailed information that is necessary when you want to do operations on it. Gives you the type and the snapshot that is being prepared from that particular EBS. So you can reconstruct it from that snapshot. And you have to be careful because when you destroy the systems, you have to destroy the snapshots as well, otherwise that costs money too. And you can see the availability zone also, not only is for EC2, also is for EBS. So what happens if your EBS is in a different availability zone and EC2 is in a different availability zone? Anyway. It's not possible. It's not going to work. So, some people ask me, if you want to do the load balancing, can't you just put the EBS into different places? And I said, no, we cannot do that. They have to be orchestrated with the EC2 that you have. So you cannot distribute your EBS. They all have to be in the same availability. We have also encryption here, not encrypted. The KMS actually is not allowed in Germany or in Europe because of the GDPRs. Because when you create the encrypted storage, what happens is the key management is basically managed by AWS. And that's against the GDPR rules because you cannot prove that they do not have access to your private keys. Because it doesn't matter how many keys you have, there is one key that can unblock all the keys that you have. We were not allowed to use this in my previous project because of the GDPR rules.
And each EC2 instance has one EBS volume, correct?
Can have more. We can expand
one
it.
more, yes, but you cannot use one EBS volume for two instances, correct?
No, you cannot, correct. Very good questions, we're going to cover it in a second. Because you're saying how to distribute our file system between two EC2s.
Yes, we used in Helfel project EFS for this.
Exactly, that's what we use.
But it's not working well.
Okay, we get to that in a second. And I'm interested to see why it didn't work. Now we have load balancers set up 0-1. Would you like to have a breather before we continue? Or can we continue on? Continue. So, you can also implement load balancers on the AWS. In this particular case, you have the LB, which is FAB-IT Solutions, and the protocols, which normally is HTTP or a particular TCP. In this case, is 8080 again, Tomcat. But if you add the SSL or HTTPS, then it gets a little bit more complicated because you have to create certificates. Now, for this purpose, we didn't have to have a public certificate, so I created a self-signed certificate. We don't have to cover that. It can be a little bit complicated. If you're not interested, we can go through it quickly. So you need at least two different availability zones that we mentioned before. So that will be the FAB-IT Solutions 1 and 2 servers on two different availability zones. Then you have to create predefined security policies. We're not going to go into that again. But normally if you choose the latest one is secure enough. But that's out of the scope of this lecture. That can be itself very involving. And you also can enable backend authentication, which in this case we're not going to do because we're using self-signed certificates. At the top you can see it says choose a certificate from ACM, recommended. Choose a certificate from IAM, upload a certificate to IAM. Upload is when you have a self-signed certificate. Otherwise you have to pay for the other certificates, then import it and push it up. We are not going to spend a lot of time on this, it's one more for technicians. In order to access the AWS for management and certificate purposes, you have to have the CLI installed, and that's how you install it. It is driven by PIP, which is a Python. You do a pip install AWS CLI, upgrade user, goes through that process, does it for you. Again, we're not going to cover this. Then with the OpenSSH, you create your own certificate. So the first stage is created, we review it, you combine it, because there's a PKCS standard, P12, for the combination if you want to send a combination on. Then you validate it and upload it. And the upload is uploading to the AWS. So when the certificates are ready, you have the body, chain, and the private key. Body is the certificate, chain is when you have multiple certificates, you append them together in a chain, and you need a private key. And it is a SHA-256, secure hash algorithm 256 that's been used, which is used in Bitcoin as well. So we're not going to cover the whole thing, but quickly you can see that there's a DE, Baden-Württemberg, Stuttgart, Diconium, IT Services, FAB-IT Solutions, and SHA-256 encryption. 2048-bit RSA encryption. So it pushes it up. That's a command for it. And when it's successful, it gives you the JSON. Then when it's pushed up, you select it and you create the load balancer. And when the load balancer is up, you can see the availability zones. And when you connect to your web server, every time you connect, it connects to a different server. So if one of them is not available, chooses the other one. You obviously have the security groups as well, which we defined previously, and the VPC information. Now this is an overlook of the load balancer. You got the HTTP 80 and HTTP 443 also available. You can see the certificates if you need to. And we're using ELB security policy, which is a little bit too, no, that's actually 2018. So it's a good policy. Now, when the load balancers are up, that doesn't necessarily mean they're working. You have to still assign it to your EC2s. And that's called load balancing target group. So target group is the machines that you want the load balancer to work for. So when it's defined, then you can attach as many servers you want. In these cases, you have two instances. So you choose the instance IDs. This is very important to know the ID of it. Then you put it in the target group. Then you can see the status of healthy or not, which can be used later in autoscaling. So when you have an autoscaling, what it does is automatically add or subtract servers when necessary. So basically, you don't need the OCD, on-call duty, because if you program it well, automatically brings up the servers for you and shuts down the servers for you, depending on the health status of the server. So here we call it my first ASG, the launch template. You can create a template so you don't have to recreate it every single time. And you have to give it a group size. One instance doesn't really make sense. Normally it has to be more than one, maybe 20, 30, 40. The network and the subnet. Now when the autoscaling is configured, what happens is, according to the way that you program it, it will make sure that your service is always available. So if the server is faulty, depending on the health check and the grace period, it will relieve that server and construct a new server in place of that. And when that server is available again, it destroys the server and goes back to the first service. But the grace period is very important, and the cooldown period is very important as well. If you don't calculate that properly, once we had a couple of servers going up and down because of not having a right calculation in the cooldown period and the grace period. So you can see the launch template, you can name it, you can see the activity history, scaling policies, which is out of scope, but that can get complicated. All this can be coded. So you can bring up the whole infrastructure with the code. So if the code is running properly, basically you don't need any on-call duty. You can even put spot diversity, instant types, on-demand percentage, desired capacity, mean, max. These are very important numbers. Then you have notifications. I mean, it's not always perfect. Sometimes you have problems. You still need to have some sort of notifications. And you have termination policies, instance protection, and placement groups. There's a general exposure to auto-scaling. Any questions? So here you can see that the auto-scaling is up, and you can see what are the instances related to. Normally you'll have like 50 instances here, but I just put one. And you can see the reports. So if you come next day, you want to see what happened last night, you go to the activity history. To be able to fine-tune your code, you have to read the activities history, and according to that, you can fine-tune your code and make it better, running better. We also have web access firewall. So we have netting that we are trying to protect ourselves at the port level, at the service level, at the IP level. But these days, the attacks are getting more sophisticated. And the types of attacks are sometimes within the SQL, which is called SQL injection, or embedded within the SQL injection. That's, you can define it here to protect that. That itself is a very big theme, big subject itself, which we're not going to cover. But when you start creating the web access firewall, it gives you some templates to choose from. IP match condition example, so you can match IPs and whitelist and blacklist people. String match condition, you can look at the strings and bots. SQL injection match condition can be programmed and stopped when necessary. Then you can go to the rules contain condition, IP match condition, string match condition, and detect SQLi. And web ACL contain rules. Bad bots, suspicious IPs, SQLi checks, and so on. We created this in 2000, a couple of years ago. It was not that sophisticated, but now these days it's getting better and better. We had some problems with the web access firewall. But as I hear, you had some problems just recently as well.
Yes, we face a high load on the system, on the EFS,
Okay.
when we're using it, especially in Europe.
Is that because of the injections attacks, or?
No, I'm not sure. From time to time we had a really high load,
Mm-hmm.
and it was a problem, and then after 1 year of problems we shift back to EBS.
I see. So this is a web access firewall example, FAB-IT Solutions LB01. So we say look at this particular load balancer, this ARM, for these two subnets, and we activate it. We're not going to discuss the WAF because, you know, then there'll be a lot more. It'll be out of scope of this particular workshop, and it can get very complicated depending on the tasks that you have. So the next part is Elastic File System that you were referring to. Maybe if you have an EC2 and the EBSs are constructed on the EC2, what you can do, we can basically run NFS4. If you run an NFS4 system, it will do exactly the same as Elastic File System, but you'll have more control over it. To be able to distribute your EBSs through the NFS4, Network File System, to be able to distribute amongst multiple servers. I never use Elastic File System as a service, which you have to pay for, but as you say, you'll have lots of problems. But my feeling is the configuration has not been done well, perhaps. One thing that you look for in the NFS, you should not make hard mounts. In the ETCF stack, when you look at it, you have to do soft mounts. That's, the hard mounts creates a lot of TCP connections that they're hanging. That could have been your problem. Because you say you had a lot of loads, which means that a lot of TCPs were open because of the hard mount. That's one thing that pops into my mind. But NFS is been developed all the time, and the NFS4 it works very well. So if that problem still persists, if you send me some information, I might be able to help. So here, NFS configuration is a lot easier. So you choose your VPC and you choose your availability zones, and you need these two machines to have one mount that they can share the files with each other. And you say next. You can do general purpose or max I/O. Perhaps the max I/O could have been a better choice for you, I'm not sure. You can have bursting or provisioned. Enable encryption of data at rest. So if you turn this on, it'll make it very slow, obviously. But then I don't know what sort of rest period you have. Here it's created, but you can see the 1A is not configured, but doesn't matter really. And voila. It's a lot easier than actually creating the NFS yourself, the NFS server. So here you can see that it's running, available for general purpose, bursting, not encrypted, from local VPC, across VPC connection if it is necessary. So you don't have to have only between the EC2s on the same VPC, you can go across the VPC as well, between Sydney and here. And they're both available. Any questions? Thank you very much.